to share with you something about the investigation that I'm doing. This paper is about the archives of study in a fabric that produces injection molds for plastic parts in the industry. The name is Mold Making Scheduling by Genetic Algorithms and Petri Nets. The main idea of the investigation is to exploit the mix of Petri Nets as tool for modeling industrial systems and optimization methods to improve the metrics of interest for us. Okay, the previous work that has been done in this investigation, you can read this paper. It's the result of my magister thesis. It was published in 2006, and it established the theoretical basis to use Petri nets and genetic algorithms. It proposed a chromosome to represent in a proper way the system, the fabric, the production line, and after that the genetic algorithm is used to evolve the Petri net from the initial marking to the final marking that implies the production of the parts. But it is just a theoretical approach. After that, we published in 2011, and we showed an application of this approach in a manufacturing system that produces cover seats for cars. And it was the opportunity to prove in a real case that that approach is working. However, we realized that a redundancy in a numerical representation of the chromosome that we use was a problem. What it means? It is basically when a chromosome, the representation of the chromosome that we use in the genetic algorithms looks different. For example, number 1 and number 4. But however, the solution that it represents is the same, it's big. So that kind of problem is difficult, and it's a shortcoming that we have to avoid in order to the algorithm could stop in an early stage if we don't manage in a proper way that kind of phenomenon. So the idea of the paper that I am talking about today is to propose a modification, a genetic operator that improve, that avoid this kind of problem. And the idea is to show how important, how good is that new genetic operator. The methodology proposed was the following, was as follows. We create individuals, instance, with the following characteristics. Precedent between some pair of jobs, processing stations with machines in parallel configuration, non-identical, and the possibility of use one machine or one or some of them that is a good setup for processing in the stations the process. The parameters we use, for example, weights of the jobs, processing times of the operation, number of the machine in the stations, were obtained by use a random uniform distribution. It's a common practice in my field to obtain the parameters for this instance. The due date for each job were calculated by the sum of the processing times of operations multiplied by a factor. And the existence of a probability of precedence between jobs is fixed by a parameter too. Why this kind of characteristics, especially for the precedent between some pairs of jobs, is because when we have to fabricate, we have to produce some mold for injection parts. Some parts some parts that we produce are not in the final product. I mean, in some processes like electro discharge machining, some material are removed by the UFAN and electrode, and it is necessary to produce the electrode, but that part is not compound the final mold. So it is a special kind of production system. In order to test if the new genetic operator that we are proving, we are using, is good, we use a difference of means. We solve the instance with the different treatments, actually 3 treatments, with and without the redundancy synonymous representation genetic operator 2, and mixed integer model to have an incumbent solution to prove the quality of the solutions. After that, after solving the instance, we compute the descriptive measure for the difference of means, test for the normality of the population, it was projected. Then the Simon test of Wilcoxon was applied, and finally the conclusions have obtained. Actually, in this moment, we are finished to run in the last instance. So that is the movie. Any questions? Clear as the word.
Clear as mud.